This video is produced for students enrolled in the EPO 322 Diesel Engineering 2 simulation course held at Cal Maritime. This is the second of two tutorials covering how to complete Lesson 1 using the Kongsberg Diesel Simulator. So for Lesson 1, we are going to be bringing power up on basically a dead ship. We have no shore power available, so we will need to start the emergency diesel generator to supply power to the emergency switchboard. Then we're going to supply ventilation to the engine room using number 2 exhaust and number 2 supply fan. We will prepare the auxiliary systems for both diesel generators, and those are going to be fuel, cooling water, lubricating oil, and start air. We're going to use diesel generator number 1 to supply power to the main switchboard. Then we're going to start up all the shipboard ventilation fans, prepare all the compressed air systems, which on this vessel is your main starting air, and they have a ship service air, which is a combined ship service and control air. Then we're going to normalize the potable water system and line up the bilge system to pump the bilges into the bilge holding tank. Okay. This is the emergency diesel generator that will start up first. Of note is we can check the level of the lube oil in the sump, and you have a graphics of a gauge glass. And then also beside that, you'll see this L70. If you put your cursor over that, that tells you the lower left-hand corner that it's the emergency generator lube oil sump tank level, and it's at 70%. So we have level in the sump. Upper right-hand part, you'll see this L90, and the emergency generator cooling water expansion tank level is at 90%. So we're good on the cooling water. Our fuel tank is 80% full. Anyway, as you go through this training on the simulator, just please note that anytime you see one of these green letter number combinations and you want to know what it is, because there's a lot of available information, even flows and viscosity and different material, you'll always just put your cursor over the numbers and it'll come up. All right, to start the simulator up, I'm going to select the page and hit F1. You'll see it go from freeze to running. F2 would put it back in freeze, and you see the clock has started. We're going to start charging the hydraulic accumulator. This has a secondary hydraulic start system that would be used if the primary, which is an electric system, if its start battery became discharged for any reason. The problem with an electric start system is that problem that what are you going to do if your start batteries become discharged? So this has a secondary system. Now, if I hit this data plate, you'll see that this is a a high-speed diesel generator, 1800 RPM, 250 kW. It puts out 440 volts. So very similar in size to our emergency diesel on the Bear. We're above 200 bars, and I'm going to go ahead and shut that off. Now it's just charged up if I was to need it. You would have to use the hydraulic start, you'd have to manually do it using this start button to open this hydraulic solenoid valve. All right, so we're ready to go. I'm going to go to its engine control panel, hit the start button. We'll turn the sound off. We don't need the sound. I hear it coming up. Okay. All right. So the generator's up to speed. Next, we're going to go process directory, electric power plant. And we're going to put on the voltage regulator, and we're going to adjust it for 440 volts. About 46 seems to work pretty well. You notice our frequency is high. We're at 61 hertz. We're going to go lower that down to 60. Now, one of the problems here is this emergency diesel generator is supposed to have an asynchronous control. In other words, it's supposed to hold a steady 60 hertz, and it doesn't work very well. As you load up the generator, the frequency will drop. So what you're going to be doing when you're testing is, and as you practice, you're going to leave this field on one of your monitors, and as you initially load up this generator with the different, by starting motors and that type of thing, you're going to watch this frequency and raise the governor up as needed. I'm not going to do it because I want to have a negative indicator on our assessment so I can show you that and we can talk about it a little bit. But again, you will have to, when you are running this, you need to regulate your frequency and keep it steady. All right, I'm going to go ahead and close the circuit breaker, the disconnect circuit breaker for the emergency diesel generator. We've now energized the emergency bus. There's a hot button here, 73, that will take us to the emergency switchboard. We're only going to put on what we need: emergency fire pump and water mist, emergency operating panel, emergency transformer. That, by the way, energizes down to, this is an air circuit breaker again, it's motorized, and that green light tells you that its springs have charged. And that is for our lighting transformer, and it is a 440 to 220 volt step down transformer. And that was energized off this emergency lighting, or they've shortened it, it's emergency lighting transformer. Then emergency air compressor, main battery charger, start battery charger, both our diesel generator lube oil priming pump, the diesel generator preheating, number 2 supply and exhaust fan, auxiliary salt water, low temp fresh water pump, and the bilge water pumps. We're going to go ahead and put all our lighting panels on. We don't want anybody tripping in the dark. The captain has said he wants power to his nautical distribution panel and his radar and radio equipment, so we'll go ahead and put those on. This is our battery chargers. Now, this is these circuits will charge up and keep the all of our batteries backed up and also supply current out to the systems. So these are the backups that you have in case of basically it's a 24 volt uninterruptible supply. All right. If you forget these, by the way, this main switchboard feeds power to the generator voltage controllers, and you will not be able to raise excitation, because if you don't have the battery charger on, that battery will discharge and you won't have the power available. All right, now that we've done that, we're going to go over to the main switchboard for a second and close these two circuit breakers off the main board, even though it's dead. It's a little bit strange, but the automation for this vessel is set up so that when you're normally out at sea, all your ventilation fans are supplied off the main switchboard. And if you were to have a plant blackout, it would automatically, on these number 2 fans, switch their power supply over to the emergency, and you would have air down in the engine room to prevent it getting overly hot. So anyway, we go to process directory and we'll go to air ventilation. But both the circuit breaker on the main switchboard and the emergency switchboard have to be closed to start these 2 fans. Now that we've got that, I'm going to go start lining up our system. We have to use the low suction as the high suction is out of the water. This is their graphics for the hull, and this is your salt water outside the hull. The ship is unloaded, so the high suction's out of the water. We'll line up to the low suction through the auxiliary pump, line up one of the freshwater coolers. We'll line up both of the saltwater to freshwater coolers for the diesel generator. One supplies generator number 1, the other generator number 2. Now these big freshwater coolers, only one is necessary. They will each handle the full cooling load, and you would never really want to put 2 on. All right, then we'll follow that out through our 3-way valve, temperature control valve. Open your overboard and your recirc back to the temperature controller, or back to the suction of the saltwater pump. To answer an alarm, either hit F12 or the silent buttons and go to your alarm page to manage your alarms. All right, we know the saltwater pressure is low. We'll put in a set point of 20 degrees C to this temperature controller and put it in auto. Now, what happens is this would take a temperature, since the temperature on the outlet of the saltwater pumps, that was what this dotted line means, and then it is going to try, its set point is 20 degrees C, and it will send an output signal to this pneumatic control valve that will either send the salt water overboard or recirc it back. I'm going to go ahead and start my pump up here now. Make sure, though, that you fully line up all the systems and put their controls in automatic prior to startup of pumps. This temperature controller is for Arctic operations. In very cold water, by recircing some back to the pump, it tends to prevent the sea chest from icing over, which can happen sometimes in very cold conditions. All right, so now we've got our saltwater system up and operational. We'll go to our freshwater cooling. You have to use the same, open the outlet from the same freshwater cooler that you opened on the saltwater side, in this case number 1. Both of these bypasses need to be open. These allow the 3-way valves to work. And what that does is when the 3-way valve is trying to cool the water, it sends it through the freshwater cooler. If it's trying to bring the temperature up, it will bypass it. This is for the low temp freshwater. This is for high temp freshwater. Both of those should be open all the time for the system to work properly. The set point on low temp freshwater is 30. Go ahead and put it in auto. And then we're going to go down and open the root valve to all the air compressors. We'll go to 59, which is on the start air page. We're going to line up to both the start air compressors. These are to their inner and after coolers. I'm also going to line up to their emergency start tanks at this time. All right, that's good. Let's go back to the freshwater system, and we can go ahead and start an auxiliary pump. Make sure that you have pressure and make sure that you have a flow. Okay. We're not going to do anything with the high temp freshwater at this point because we have no heat to put on it. So we're going to ignore it for now. Okay. So once we've done this, let's go back to our air compressor, and we'll go ahead. We have to put it in local to start this emergency start air compressor. Put it in local and go ahead and start it up. Right. You notice that this particular compressor has air-cooled intercoolers and aftercoolers. This low temperature fresh water, the cooling water temperature being low is for us right now is just a nuisance alarm. We will not put start air on the generators because they have no lube oil in their sump, and to do so would be very improper. So we're just going to start filling that tank. I am going to blow it down though. You notice that you start out with about 18 bar, which actually is enough to start the diesel generator if you needed to, but it's kind of marginal. All right, I'm going to blow them down, and notice the Z204. If I put my cursor over that, that's the water content. So I just go ahead and blow them down. When they go red, there's no water content. All right, so we've got water, and we're filling our start air. So let's go ahead and go get fuel. We'll go to the fuel oil service tanks. It has to come off the diesel oil service tank. and that's the supply to the generators. Make sure that the generator is lined up for diesel. The yellow line is diesel oil. We don't have any heat to be able to use residual fuel, so that's not an option at this point. Okay. This is the emergency shutdown solenoid. I can show you that real quick. If we go to this, see it goes to the emergency operating panel, and if I trip this again, that valve I just opened will close, and we'll get an alarm that it was tripped. Okay, and then these, by the way, these are the quick closing valves on all of your fuel tank outlets. You would use any of these you would use in a fire. We can use this back button to go back. Again, I'll open it. One of the filters. Let's start filling of the sump to one of the lube oil filters. We'll go ahead and set its set point at 45. So 45 on the lube oil. Low temperature fresh water is 30. And then high temperature will be 80. So each of the generators is supplied salt water off the main system, and it has its own low temperature and high temperature cooling circuit. And the lube oil cooler is off this low temp. So these generators only need salt water supply for cooling. Oops, sorry, I got talking. I got my sump a little high. I wanted to go to 70 was where I was shooting for, but that's not too bad. We'll be okay. I'm going to go ahead and put my preheater on and my lube oil priming pump. Okay. By the way, if we hit the data, this is a 900K dub generator running at 900 RPM. Sound like the training ship? We've got number 1 done. Let's go ahead and do number 2. I'm only going to run one, but I want both of them ready at any given moment to be able to use. There's no reason not to have both ready. All right, so same exact drill. Okay, 70 is where I wanted it. We'll put our lube oil priming pump. Fuel's good, lube oil's good. I've got pressure, I've got flow, 45, 30, 80, preheater on. So we're good. All right, I'll double check my main diesel generator again real quick. 45, 30, 80, preheater on. We're good to go. So now we can go ahead and put air on it. It's ready for startup. So we'll go ahead and put air on it, on both. No reason, again, not to have both ready to go. Standard on an unmanned service UMS vessel that you would have both generators ready. All right, we'll go ahead and start it. You can see our RPM coming up. We will get a lube oil low temperature and a jacket water low temperature. That's because we didn't have any power available to preheat the generator. It's not going to hurt it this time to start it cold. We're going to watch our exhaust temperatures come up. Okay, we're good. All right, I'm going to go ahead and put this generator on the line. Go to generator number 1. Put its excitation on, about 50%. It gives me right at 440. I'm a little bit high on the frequency. We'll lower that down. And we're gonna, right now, our main bus board is dead, so we're not paralleling. We can go ahead and put that straight on the board. All right. All right, so we're on the board. And I'm going to switch over power to the emergency switchboard. Watch when I close this tiebreaker on the main switchboard. you'll first see this disconnect breaker open and power is lost on the emergency. Is the jacket water low temp, and your pumps will drop off. So this disconnect breaker opens, and then the emergency bus tie will close. Watch it happen. Okay, that opened and then that closed. All right. So we've lost power on our pumps. I'm going to go ahead and I'm going to stop the engine, the emergency diesel generator. And then a little trick is just follow the alarm button. That'll take us right over here. Cancel the alarm. Put our salt water pump back on. Low temp fresh water. And then let's go ahead and start up our emergency start air compressor again. All right. Now, let's go put our electrical power on from the starters. Let's go ahead and get all of the fans. We need the main saltwater pumps, the main low temp fresh water pumps, all of the compressors, start airs, service, plus both fire pumps. On the feeder page, we want the fire station, main lighting transformer, sanitary and fresh water, low temp, again just a nuisance. Lube oil makeup pump, freshwater makeup pump. Let's go ahead and close the breaker and start powering up the lighting panels. These panels will go to our automation on the engine control room, and I will get an alarm as I power those up. Also on your minor panels, and what they're calling these miscellaneous panels. All right, these are off the main engine auto chief, and it's just the automation when it powers up is telling you that it's not configured correctly, which is fine at this point. All right, let's go get our ventilation. We're going to put on the fans to each of the different rooms, the house accommodations. And then we're going to run 2 of the supply fans and 4 of the exhaust fans. And that'll give us a fairly balanced engine room pressure. With a fresh water system, and I'm going to transfer some water into this expansion tank because it's low. We'll want to pump that up about to 1 bar. And now I'm going to go and start putting on my compressors. I'm going to start with the service air, line up the water, its discharge into this service air tank, its outlet. This is going to your control air, and this was going to each of the service air loads. I'm going to have it in remote. Whoops. Then I'm going to go up to the start air system, and I'm going to make sure everybody's in remote. And then we're going to go to panel directory, pump compressor control. Master is the lead. This is lead lag. Go ahead and put all of our compressors in auto. Once we've done that, I'm going to go to the intercoolers on the service air system here in the main bottle. And I'm going to go ahead and drain everything. Okay, do the same with the main start air system. Okay, so we've got that filling. All right, let's go ahead and look at our potable water system. We'll go ahead and open the line from the pumps to fill it. Its outlet to the system. This valve goes up to the engine room. This is to the house. All right, so the potabilizer is an ultraviolet sterilizer for drinking water. That goes to the tank, and this is the outlet from the tank going to the house. Then we'll go ahead and open the fill for the hot water tank, open its outlet, and go ahead and put the pump control in automatic. That will start one of the potable water pumps. All right. We'll leave that fill for a little bit. I usually fill this to about 1.5 meters. And then what I do is I will add some air to give it an air cushion, but we'll let that fill for a while. Let's go ahead to our freshwater system. And we're closed, but we're still not full yet, so let's go to our bilge water. All right. On the bilge water separator, we are going to be pumping the bilge water into this dirty bilge water tank. In today's world, you basically store it while you're in port. We will not be using the oily water separator at this juncture, because since we are in the shipyard, it would be illegal to pump bilge water over the side, even though it has gone through an oily water separator. Current regulations do not allow that. So go over to the bilge system. We'll go ahead and put our bilge pump in auto. It will automatically start, and it opens up the appropriate solenoid valves to pump down these sumps that are high. So that's good. So let's check back. All right, we're at 1 meter. We can go ahead and shut that transfer pump off. Check that I didn't forget. I think I did. Yes. Always check. I did stop the generator, but I forgot to put its control in automatic. That's easy to forget, so always check on that. All right. Let's go look at our start air system. Pressure's coming up nicely. A little faster than what you'd have in real life. Potable water. All right, we're close. May let this fill for just a little bit longer. We're coming up on 25 minutes, and you notice I haven't been in any particular hurry, and I'm basically done. All right, there's 25 minutes. That's a reminder. We'll go ahead and put on our cushion air. You'll see your pressure will come up pretty fast now because I'm pumping water in plus supplying air pressure. And I'll usually just give it enough cushion air to clear the alarm. Let me go ahead and shut that off. I'll go ahead and put my hot water circ pump on at this time and my electric heater. All right, so let's go back and check our systems. Our saltwater system looks good. Low temp fresh water, the freshwater cooling, that looks good. Tanks are still coming up. Okay, everything is looking pretty good. Let's go back to start air. Now, one of the things I want you to note is this check valve here. You see the green arrow pointing towards the emergency start air tank. What that means is that I can use one of the main start air compressors to fill this emergency starting tank. But this emergency start air compressor cannot be used to top off these main start tanks. It's a fairly small compressor. It is air cooled and it's run off the emergency generator. My impression is that you would not normally use this air compressor, that it would be there for exactly what we're using it for, to fill up the emergency start air tank if you don't have power on the main switchboard. So I'm going to bottle this emergency start air receiver up once we've cleared the pressure limitations on these tanks. And I'm doing so because if there was some sort of an incident that we lost all our start air, and these tanks individually are 3 or 4 times bigger than that emergency start, 3 times bigger. Whatever event would drain those, we don't want it to drain this emergency start tank. We want it to be full all the time. That way, if we had some sort of an incident, and again, when we'd lost all our start air, I know I have start air available to be able to bring my diesel generators up. So we're pretty close to clearing the alarms. I'm going to open up from one of the receivers, and it can go down. Again, the green means that it will go to our generators, and I'm going to go ahead and shut the outlet from the emergency start compressor. All right, we're now at 28 minutes. And let me check the freshwater system again. Okay, I shot that down. All right, at this juncture, I can bring over the assessment. We still haven't gotten one green, but that one is we have to run the simulator for 29 minutes. We've had a problem with the students rushing through this scenario or any of the scenarios, and in their rush, they forget certain things and they end up failing the assessment. So we want you to use all the 30 minutes allotted. Okay, so we've gotten the 29-minute flag. That is completed. I'm going to go ahead and halt the simulator at this point. And I want you to note that we have all greens, and the only red is the one that I talked to you about, and that's on. I did not control the governor to maintain its frequency at 60 hertz. Now, let's talk about the assessment editor a little bit. These green arrows are critical achievements. So to pass this assessment, I have to have the saltwater system operational. The main switchboard must be energized. The service air compressor must be on and the system normal. I must have pumped the bilges. The ventilation needs to be running. And then the start air system needs to have started its filling process. Then each of these other green indicators are additional assessments that add to that, I don't want to say grade, but add to showing that you have correctly completed the assessment. Now, if we come down a little bit, these X's are critical errors that you cannot make. If you open the emergency build suction valve, this valve, if I opened that, I could pump bilge water out of the bilge and it would go through the saltwater system and over the side. That would be a critical error. What's going on here is that emergency bilge suction is only used for a flooding incident. The vessel has had some sort of a casualty, the engine room is flooding, and you need another bilge pump. In that case, you would shut off your low suction sea chest supply and you would open your emergency bilge suction to use the bilge pump to pump the engine room. Now, that while that is acceptable in an emergency, it would cause a pollution incident if you did that under these types of circumstances as of this lesson is set up. So you will fail the assessment if you open the emergency bilge suction. Lockout violation of the SSDGs. That is putting start air to the diesel generators when there is no lube oil in their sumps. Backfeed. If you activate the backfeed. Backfeed we'll talk more about in our lecture, but that can only be used under the direction of the chief engineer. It disables a fairly important safety interlock, and a third assistant would not utilize backfeed unless they had okayed it with the chief engineer. So you will fail the assessment if you use the backfeed. There's no reason to use it in this scenario. Number one or number two, start air compressor tripped due to high temperature. That's usually because there was no cooling water to them and they overheated and shut down with damage. So you'll fail the assessment for that. Bilge pump water overboard. This is if you run the oily water separator to pump bilge water over the side. Again, in today's world, that is not legal while you're in inland waters. All right, so these are all the negatives. And so for an outstanding, what I want to impress on you is that you want all greens and no reds. Now, when one of them pops up, I also want you to know that this was a negative, but the students like looking at this score. And this score means is not the score that you're graded to for a big reason. This score is primarily composed of the positive factors. Negatives have very little effect on it. And you notice I did have a negative, yet it had no effect. So the only thing that this is used for is you have to, in this case, have to be over 70% to pass the assessment. If you get negative indicators, the instructor will look at each of those and determine whether and what the appropriate score reduction would be. All right. So again, this assessment editor doesn't work where we can use this directly as your grade. Any of the negative, and you should have very few, would have to be assessed by the instructor to give you your final grade. So we've scored above 70%. All our critical achievements have been met. No critical errors, and our assessment is positive. All right. I hope that has been informative for you, and I will see you in class. Thank you very much.